All right, if you're happen to be following along with notes, then you know that I skipped a problem in that last video. And the reason I did is because I wanted to put these two together. We have a couple of really interesting situations that happen with absolute values that I wanted to talk about here. So let's just look at this problem to begin with. It says the absolute value of 6x plus 5 is less than negative 1. Well, let's just stop and think about that for a second. Every single time you take the absolute value of the number, doesn't matter what's inside here. Let's say that whatever's inside here turns out to be I don't know, a 10. Then the absolute value of that would have to be positive 10, right? What if what's inside here turns out to be a negative 10? What would be the absolute value? Well, again, that would be 10. No matter what we have inside the absolute value symbol, once you take the absolute value, it will always be positive. So there is absolutely no way that this absolute value could ever be less than a negative number. To be less than a negative 1, you would have to be negative 2, negative 3, negative 10, negative 15.345, anything that would be to the left of negative 1 on the number line. And there's no way that that's going to happen with an absolute value. So there is actually no solution to this problem. We can't even work it to begin with. Now, another interesting situation that comes up sometimes looks something like this. Here we have 2 times the absolute value of x plus 3 is greater than 1. So what we need to do first is we need to get our absolute value alone so that we can work with it. So I'm going to subtract 3 from both sides to get 2 absolute value of x is greater than, if I subtracted 3 from both sides, that would be a negative 2. And now if I divide both sides by 2 to get this absolute value alone, I would have the absolute value of x is greater than negative 2 divided by 2 would be a negative 1. Now here we can do this because we can have numbers that once we take the absolute value are larger than negative 1. They just can't be smaller because that wouldn't work. So let's pull this out and separate it out so that we can see what's happening here. We have either x would be greater than negative 1. We could also have the opposite of x would be greater than negative 1. Now, because this is greater, this is an or statement, or another way of looking at it would be a union. You're joining together of these things. So our first part is done, but our second part here, negative x greater than negative 1, we need to divide both sides by negative 1 in order to get x alone. So x would be less than positive 1. Now let's look at this on a number line to see why it's such an interesting situation. Here we have 0, negative 1 would be over here and positive 1 over here. Now because we're going to be joining these things together or unioning them, we can just go ahead and put them on the same graph because we don't have to intersect them. Intersecting you really need to do separately and then look at where they meet. But for a union, you can just do them on the same exact line because you're going to be bringing them together anyway. So our x's greater than negative 1 would start here at negative 1 and continue to the right for greater than. Our x's less than 1 would start here at 1 and continue to the left. When we join these things together, we're talking about the entire number line. So our solution here is all real numbers, or negative infinity to positive infinity.